Hello, everyone. So, welcome all to this knowledge
Hi,
session.
Piyush. Hi, everyone.
Hello, everyone. Hello. So the topic for this knowledge session is best practices in Scala. Though it says Scala, right? What we have, what we have decided is like let's follow our product development life cycle, our usual like coding practices, right? And see like how exactly we should work on. What are the best practices or principles that we should follow, right, while coding? And whatever principles today we would be discussing, right? Those are not new or like weird principles or strategies. Those topics are very easy topics, and I'm 100% sure you all would have uh, gone through them. Not sure if you have actually used them, but the idea here is to make sure that yes, there are few best practices there in the market, right, which we should use while in our product life cycle. And that's why like we have defined this topic as best practices in Scala. Say, for example, taking Scala as a development language, and DTMM stands for development, testing, monitoring, and maintaining. So in your generic product lifecycle, right, you do development, you do testing afterwards, you then do monitoring of whatever you have developed, right, and then finally you do the maintenance part of it. So we're going to talk about some of the good features or good practices that we should follow among these four life cycles, part of the life cycles, right? So let's move on. Well, let's go to the next slide. Okay, and following up before, let's get to the knowledge etiquettes, right? So you all should know all of them, and most importantly is the feedback session. So after this session, right, please do submit your feedback, and 100% it actually help us out to improve in future. Okay, and at the end of the session, like we'll have a quick question and answer session. So wait for your all the questions, and we'll tackle them at the end of this session. Okay, so as I said, like we'll be developing, like we'll be covering up these four topics: developing, testing, monitoring, and maintaining. So in developing, we thought of these three topics which generally we should use in Scala, right? I'm not sure how, and we'll discuss like if you guys have used them, till what extent have you used them. Then on the testing part, we'll see, okay, how do we actually do the testing on local, right? And I've seen in many projects people do suffer doing testing while running everything on their local, right? Exploding their system while running thousands of applications behind. If they are using any third party tools, right, we generally tends to install them up, which is not a good practice. Plus uh, how do you run your Scala application also, right, or any application, say Java application, anything. Then what are the ways you should monitor your applications, apart from very generic monitoring? Nowadays, right, you have tens of thousands of topics down there in the market, where you actually should monitor your applications in different domains. So we're going to learn about them. We're going to view some demos also. And finally, like how should you maintain your code quality, right? Though we do follow clean code, we do follow generic principles, but there are certain tools also which I think we should always look into them and try to enforce them in our projects for it. Okay, let's go next. So let's start with the development part. So the first topic was that parallel collection, right? Now, before starting, right, a quick question: who all actually have used this topic or this library? It's called Scala Parallel Collections.
I've
None
not
of
used it,
you?
but I've seen it being used in my project.
Okay, that's
Not used it
also
personally though.
that's also a good start. Uh, but that's why like we actually picked up this topic is because I was 100% sure like many of us have actually not even seen it, and beyond of using it, right? And it's a very beautiful like concept of doing parallel programming. So you would all have known, right, that future is one of the way you do parallel programming in Scala, right? uh, Threads are another way, using direct threads, which we do not use, of course. Aka was another way, right? Aka actors was one of the way, and then the fourth way, which nobody talks about, is parallel collections, right? And the beauty of these parallel collections are that they have been like blended with our normal sequential collections that we have in our Scala. That is like array, vectors, right? Hash map, hash set. We all have used them. List, uh, range, and so on, right? And what this library does, it actually helps them out to parallelize these working of these collections, and gives you like multiple threads opportunity to utilize those multiple threads on there on your code to do your function parallelly, or to do your processing parallelly basically. And how does that works? So it follows the basic concept of divide and join rule. I don't know, map and reduce rule, right? Yeah, you can say map or reduce or divide or join, divide or conquer rule. So whatever data you have in your particular collection, right, it divides that data into parallel threads, perform your operation, whatever you want to do, and then basically joins back the result set and produce you back the final result. So so if you feel like if you say like where to use them, right, where to use them, where you have a list, where you have any of this collection type, right, and you don't, your sequence doesn't matter, right, the operation that you're performing in your list, it doesn't matter, the sequence doesn't matter on it, then go for it. Nobody is stopping you on that, on it, right? If the uh, side effect doesn't matter, for example, say you're working with a mutable type, and in that case, right, if you perform parallel operations on a mutable collection or a mutable some say variable, right, that the result may hamper. So if that is not the case, then nobody is stopping you to use parallel collections, correct? So the idea is, try to explore this parallel collection, and also I think we do not tends to look at this topic because it's not readily available in the basic Scala library, right? You have to export a different library for it, and it's called Scala Parallel Collection Library. And mostly it is more suitable with 2.13 version. Otherwise, like all the lower versions of Scala, you have to do some hacks or have to like do certain imports, which are of course not that much difficult. But yes, there are ways to do that. And then this particular library explains. If you go on this GitHub like repository, it explains you how to use them with the detailed instructions and all, right? We'll give you a quick example also, and we'll showcase you how exactly it actually matters, right, using these parallel collections. So quick, like the last two lines says, how do you use them, right? You have, for example, if you use this library, you have pair vector. If you want to create a pair vector, you use it with a new keyword. Or there is a pair method also. So if you have a generic collection, right? So for example, in this case, there was a vector, right? If you want to parallelize it, you just use this pair method on top of this collection. So if you go to the next slide, we have an example of how to use this pair method. Okay, so in this case, you see, right, we have a simple list, say example, and I was iterating through this list, and say in that list, I do have some uh, some computation that we need to do, right? Time consuming computation. So we have a sleep of 1 second. And I was just like, say we were just counting all the elements from this list, doing the simple addition on top of it, right? So if on the left hand side, if you see, right, a simple list, this operation took almost more than 10 seconds to complete because we had a sleep of 1 second, right? So eventually it will take more than 10 seconds. But similarly, like if we would have converted this sequential list into a parallel collection list using this par method, it actually parallelize what we already discussed, right? Parallelize the elements inside this list, and this took less than 2 seconds even. So you see the power of using this uh, collection, right? Any questions anyone has? Uh, I don't know, Prakhar, you said you have seen that, right? Which do you remember? Which collection was it? How was it being used in your project?
Yeah, I think it we were doing some heavy intensive IO operations on a sequence, and therefore we
See,
used dot par on it, and
excellent.
then map to have it parallelized. I think it was that
The
was the
same.
use case.
Okay,
So
kind of similar
basically, it will
example
be, yeah,
which we
it
have
will be
here.
useful for basically batch processing when we don't have to maintain the
Order.
like the order, yeah,
Yeah, order.
indexing
Yeah.
or order. So I
Yeah,
think that will be really a good example for making it parallelize.
Hmm.
correct. Correct. So that's the whole idea of using these methods, right? Okay, let's go to next topic. Next topic is monads, right? I think this is also something which we all have been using unknowingly, or I don't know, knowingly. Few of these like monads, for example, try, I know everybody would have used for comprehensions. Either we have used for error handling, right? Future patterns we have used, right? But there are other like inbuilt functions that monads provides us, which actually helps you out to make your program more functional, right? Rather than doing imperative coding, or rather than doing non-functional coding, monads actually helps you to handle your most side effects in more functional way. So uh, yeah, again, most common topics are like you can have custom monads, right? Simply you can have collections, whatever collections you have, those if you use them in the for comprehensions, they actually wrap up your result, right? The processing results that you're trying to do in that for comprehension. Then you have option monads, right? All of us know that rather than how to handle nulls in Scala, right, it's better to use option. So options helps you out to either have some value or have none value, right? So that is also a type of a monad uh, in this case. Then there are flat maps that you use, right? So monad has its inbuilt property. There are two functions that it uses. It's called bind, and I'm forgetting the second one. I think it was bind and unit something. And bind is actually related to flat map. So the way that we use flat map, right? The way that we use maps, that all actually is being controlled by this topic called monad. Then you have try monads. I didn't have those, like I didn't added the code, right? Because these are very basic principles, and I believe like everybody would have used them. But like try monad, in case you want to evaluate your operation, right, into a success or a failure, it's better to do wrap it into a try, correct? Then for comprehension, we all know. Uh, I think futures everybody would have worked on, correct? So these are the basic, I think, topics which actually help us to kind of do our error handling in more appropriate way, right? Evaluating the side effects. Plus, I think if you deep dive into monads, we don't want to deep dive here now, but at least like if you go a little bit deep, then there are concepts of binding and chaining that we talked about, handling other side effects, right? The basic monadian structure, if I say. So, so there are other topics, right, which one should actually look into it, learn into it, and then try to implement them in your projects. Okay, perfect. Let's go next. Okay, I think that's all for testing. There are various other topics also, but what we thought, like, let's keep it simple and concise. Let's keep because we might be reiterating this knowledge again with some new topics, right? So idea for today is like, let's start learning, like after this knowledge ends, right, from tomorrow onwards, do go and start learning about parallel collections. Do go and start learning about monads, and try to start implementing them in your projects, right, in your day-to-day coding. So that's all for the development side. Now let's discuss about testing locally. I don't know, Pallav, I keep on hijacking your session, right? Do you want to also talk about something? Or
Yeah, so basically, let me reiterate for the development side only. Uh, so basically, right now we are making the applications that are very scalable, and we want very fast processing. So for that, we at the end we need to make the things parallelize, and uh, like we are already using futures for it, which is why Scala is famous. And yeah, if we further break down the futures into other parallel collection, then that would be great. Our throughput will be definitely really good, and that's how basically we should develop these applications so that it can handle much load and make these applications scalable.
okay, perfect. Okay, let's talk about testing now, right? So again, a quick question. Let's go to next slide, and then I know we do have defined the answer, but generally, what I have seen, right? Do you guys install your third-party apps locally, right? plus the answer may be yes by some people, right? Maybe no, because I know everybody is aware of Docker, and people do have started using Docker containers, Docker for our third-party tools, may it be Postgres, Kafka, anything, right? Uh, am I right? Right?
Yes.
Do you
Yeah.
guys use Docker, right, extensively? Okay. And then the next thing, right? How do you run your application? The main concept lies there also. Say, for example, you have I've seen, right? For example, in one of our clients, they have like hundreds of microservices with them. Now, to test them out, right, you have to run say 5 or 6 microservices parallelly, and that's how like you overburden your system. You cannot, I don't know, like in a generic for our generic laptops, right? We do not have more than 16 gigs of RAM or 8 gigs of RAM. Now, if you run you run these third-party softwares also locally. You might be running IntelliJ, you might be running other services on your laptop. Now you have to run 5 Scala services in parallel. That actually basically overburden your system, right? So, what do you guys use anything else to do that? Any other technique or any other way? Or maybe I'll ask, like, have anyone used Docker Compose specifically to bundle up your application into a single Docker container and run it up? Nope, nobody has used Docker Compose.
I guess everybody has used in our like most basic project or the most valuable project that we have, leaderboard. It's also based on Docker Compose, and so I guess everybody must have used it.
Okay, but people are silent because they don't want to speak. Then,
They don't want to answer the upcoming question.
oh, I think we forgot to mention this, right? I think whomsoever answers the most, they do get the reward, correct?
Yeah,
So I
yeah,
think,
right.
yeah. And Pallav also has extensive reward of $100 for him. There's a top up on that, right? So whomsoever we finds is more interactive, is answering the right in the right way, he too gets $100 rewards also. Okay. So how do we use Docker Compose now? Okay, let's take an example, right? Pallav, do you have any example to showcase?
Yep.
Okay. Okay. Go to. Okay. So this is one example, right? So you see, Docker Compose is nothing, right? It's an extension of your Docker containers to compose all your containers into one file and then run them uh, interchangeably or connectively. The best way, the best advantage that you get is like you can club all your application into one file, and then if your applications are independent on any other services, right, you can also easily provide networks to them, you can provide volumes to them, you can provide different settings to them, and then you can segregate all of your application into different YAML files and easily can run them through Docker Compose. So for example, in this case, right, in this Docker Compose.jobs YAML file, which is highlighted here right now, you see there are two services down here. One is Kinesis to Kafka service. One is like TSV2 Proto service, right? So we have defined like two services, and then both of them uses like, sorry, the above one, Kinesis to Kafka service, it uses local stack also, right? So you see in the network part, we have defined, okay, there might be a local stack running somewhere in the Docker container under the network called streaming underscore local stack. So do use that same network to connect to the local stack. So you see now there is no dependency on where to run your local stack, where to run your XYZ, right? Third application, which port to run. How do I specify that port in my application conf file every time I run and try my laptop switch off? I want to run it again and again, right? There are no hassle of doing all those network connections and everything. Similarly, if my Kinesis to Kafka would say, for example, this application might have to interact with TSV2 Proto application also, right? I don't have to specify a different settings for it. I just want to put them into the same network, which is called say XXX in this case, right? And they have the same network for the connections. Then on the sequence wise, I can also define, okay, my first application will start, my second application will start under the same container. So it is totally abstract way to run these services, right, on your system. which has nothing to do with whatever is running on your system, right? Apart from this container, outside of this container, correct? Similarly, this is one of the way I think which everybody should use while they want to test it out their application, and this also actually helps you to do your integration kind of testing, right? Once you are done with your whole development, now you finally want to test it out, and you also want to see. Sometimes it happens, right? You might have tested it on local, then you push your code back, and then your Docker Compose file creates your service, get deployed in production, and there's something went wrong, right? And then you see, oh shit, I haven't, or maybe the container is not created properly because you haven't tested it out. So doing this also helps you to test it out. Okay, my whatever I have developed, it is actually been perfectly tested from unit testing till my integration testing. That is even till my packaging and deploying it, not exactly deploying, but till the package, till it has been packaged into a jar file or into a Docker container, and I have tested it from there also. Now there is no difference between running a Docker container on your local or running that same container on production. So you would be 100% sure that okay, whatever I have developed is totally correct, right? So one of the ways to use this, second, like the second file that you see, right, Docker compose.kafka YAML file. So this actually determine, okay, all my third-party services that I want to run, right? For example, in this case, Zookeeper was running, Kafka was running. Local stack is for your AWS replica, right? Local stack was running. I think if you scroll down, you would have other services also running. So you would have defined all of these services. You do have an option to provide environment variables according to your need, right? You don't have to worry about installing them now. You don't have to worry about configuring them. You don't have to worry about specifying extra memory, extra RAM, extra storage for them. Whatever you feel like I need for my testing, just define that, build a Docker file, this compose file, run it up, and you have everything under your control, right? And when you are done with it, just switch it off. No more still extra burden on your system. Everything is being closed now, correct? And easily you can connect as you define the network settings that we just saw, right? Your applications are also able to connect with this unknowingly where it has been running. Unknowingly, you have to set it up all the port settings and blah blah. So things under control. So hope like so the idea was to iterate, okay, yes, we might be using these concepts, we might be using some of our services locally, some of our servers in Docker, but from now onwards, let's start focusing on using 100, let's move 100% to Docker, right? And use 100% Docker Compose file to aggregate all your containers, aggregate all your services, and finally run them. Okay, done. Any doubts, any questions anyone has? No. Okay, let's speed up. I think we are almost half an hour into the knowledge, right?
Yeah.
Okay, I think Pallav, I'll let you now uh, move on. It was your knowledge, I think. You
Yeah.
dived me in,
So,
but you go on.
yep. So monitoring. So monitoring is, as we know, is a very important part of our SDLC software development lifecycle. And to like the importance of monitoring is equal to having a really good code in production. So even like after deploying your application to the production, it's a very big and important step to keep monitoring your service, how it's performing, what is the basically how your APIs are running, what are the errors are getting, what the response time is. So monitoring is a very important practice for observing and collecting the data about the behavior and the performance of your system in the real time environment. Because when we test our code, when we test our service in locally, we have a very different setup, whereas when we test our services on production, it interact with the real time data where things are different. It's not bounded how we are actually using it. So any type of data can come and your service can go down in a second. And you so basically the idea behind monitoring is to like keep tracking and various metrics, logs, data sources to keep ensuring that everything is operating as expected, to identify and address the issues when they arrive. Monitoring like plays a very important role for maintaining the reliability, performance, and security of the application, because like our user experience matters a lot when they basically interact with our application. And if it is not working fine, or the response time is very high, so it might have a very negative impact on our client as well as the end users. So that's the importance of monitoring. And like there are some key features which should be basically taken care while monitoring, that is like the early issue detection. So if we basically allow monitoring to detect the problem and resolve the issue as soon as it occurs, because uh, when your application is running on production and user faces some problem, it must be annoying for user and client, both of them, to basically keep getting those errors, those problem, and it might have a very negative impact on the image. Then we have a performance optimization. So monitoring provides the insights in your performance of your application, enables you to identify the bottlenecks and the slow components that need to be basically optimized, and the inefficient code. So that really helps you to optimize your application to deliver the best output as possible. Then we have a resource management. So by monitoring the CPU, the disk usage, the network, and uh, these component, you can ensure like your application is using the right resources, and this can reduce the operational cost as well as avoid over over costing of your application. Then we have security and compliances. Then so basically, if there is any security related breach or vulnerability, then monitoring helps you to identify the issue as soon as possible and resolve the issue. It allow you to respond very quickly to the security threats. Then we have like a data driven decision making. Like after monitoring the data and the logs, we can we can define what should be the uh, correct form of uh, basically how we should treat the things, data in the data analytics, and how we should invest with the business objectives, what
May-
type of data
Maybe
is
maybe
being.
Pallav, you can go to next slides, right? And then whatever you're talking, people will
Yeah.
read that also. Meanwhile, what I've done, like I've added a poll, right? I think what all types of monitoring, or what is the max monitoring that you guys have done. So let's see, like, do start answering that vote. Put on your vote in that, and then we'll see, okay, uh, where people are actually doing the monitoring, right?
Yeah, yeah. So
And by mistake, I think I added it as a single option poll, so you'll have only one option to select, but maybe vote it again and again. Go on,
yeah.
Pallav.
So basically, this is the importance of monitoring, and only by checking logs of the application will not work. Uh, like nowadays, we need to take a step ahead and take care of these things as well. So there are like a lot of tools available in market for your application management or monitoring. So there is a Datadog, there is Prometheus, there is Grafana, Zabbix, Nagios, and there are basically a lot of tools which are available, and a couple of them are free to use and monitor your application. It is not specific to Scala application. You can use any application for uh, you can use any tool for monitoring any of the application. So in this knowledge, we'll talk about Datadog, which is not a free tool. but has definitely a very good capabilities. So let's talk about it. So Datadog is a very popular cloud-based monitoring and analytics platform designed to help organization gain the comprehensive insights into the performance, availability, and security of their application and infrastructure. It is widely used by companies to monitor complex, modern, and dynamic environment, making it easier to manage and optimize digital operations. Datadog is particularly well suited for cloud native application and microservices architecture. So we are using Datadog in our project, and it is very helpful. It has a lot of features that helps in monitoring. So like recently we are preparing for the Black Friday and Cyber Monday sale, and during that sale we don't have access to our databases. We have a code freeze. So what we have during those days when we have like a huge amount of traffic to our application, then we what we can do, we can only monitor our services, how they are performing, what is the issues going on. We can then track it later. So it provide a lot of features. So there are some features and capability. So real-time monitoring. So Datadog provide a real-time monitoring and alerting capabilities, allowing organizations to detect and respond to the performance issue as they happen. This includes like tracking metrics, logs, traces, your API responses, your API traces. If it is failing, then what exactly, where exactly it is failing in the code, which function it called and does not return the valid or expected output. So it is really helpful in debugging and fixing the root cause. And
Maybe
then we
Pallav, I
have,
think we have only 9 minutes left, right? So do
yeah,
you want to
okay,
showcase something which will excite people also? Meanwhile,
yeah.
I think guys, you haven't voted. I see only 5, 6 people have voted. You just have to choose one option and submit your vote, right? Let's see what all
Okay.
things you have actually monitored. Okay, go on.
So I also voted. Uh, and in
Okay.
the meantime, this is a sample Datadog dashboard look. Uh, it's completely based on the matrices that are published from your applications, and we can generate these dashboards for monitoring purpose through the Datadog UI. It is very handy and very easy to use, which provides like a real-time responses about the metrics that we are publishing. So we have created like a huge number of dashboard for our project as well. Unfortunately, I cannot show those dashboards here, but yeah, this is something what we can achieve from Datadog. So, and it's a very like a it's only one part of the Datadog. So one very important part is the application performance monitoring. So as you can see over here, these are all the API calls that are made to our application, and it shows you the response code, what status this API is returning, what is the issue, which type of API it is. It's a get API, post API, put API. So it tells you that. And if you just click on this API, it give you the traces, like what path it followed and what are the methods it basically went through. And if it is failing, then what, like it will tell you in the code which exactly method failed to return the expected response. So it's a 7-second video. Let's go through that. Yeah. So as you can see, we can provide our inputs over here. You can see these errors. These are the traces. Like if you can see, this is a controller shopping cart checkout API which has been called. You can see how the traces looks like. You can see these methods, these calls, how exactly it is making call to the service. Let's move ahead. Okay, so let's talk about the log management and how we can manage our logs. So in our project, we use Sumo Logic for log management. So Sumo Logic is also a cloud native machine data analytics platform that specialize in log management and monitoring the real time insights. It provide organization with tools and capabilities to collect and store the data that that has been used, uh, that has been generated uh, from various sources, and help them to gain valuable insight into the health, performance, and security of the application and infrastructure. So let's see what are the capabilities. So it provides us the log management, real-time monitoring, log analytics, securities, integrations, API and data collection, comprehensive search. So it's very easy and maintainable. It's very easy to integrate with your application as well as your uh, chat, whatever people use. Like if you use Google, then we have a Google chat integration. For Slack, we have a Slack integration. So it basically pop up the notification through the webhooks. And what you need to do is integrate your webhooks to the Sumo Logic's webhooks to your chat application, and then you are good to go. You'll be getting the alerts that you set up in your Sumo, and you'll be able to get those. So these are some of the monitors that anyone can create for as a part of monitoring and log management. If you can see over here, this is critical, so you can get a notification in your chat, or you can create a Jira ticket uh, for basically this issue and resolve this issue. You can see these alerts, warnings, and these are the monitors that are working fine. All the data looks good. So these are some of the capabilities from Sumo Logic. You can see this is a very generic log management. We can search our logs that are published from our application. Uh, we'll get it there. We can set up the timestamp on the basis of when we wanted to search that log. We can create multiple alerts, notifications, monitoring. There are a lot of function. This log reduce function basically tells about the number of times that log populated within that timestamp. So there is a lot of features that are provided in Sumo, as you can see over here. So this is a monitor that tells about this like issue occurred this between this timestamp, and the occurrences between 0 to 10, and these are the graphs for that issue is occurring. So it is very useful and very handy to basically use. So let's move forward. So let's talk about maintainability real quickly. So yeah, so there
You
are
have 2 minutes, Pallav.
yeah, so we have couple of things we should take care while deploying new changes, and for the sake of maintaining your old code. So one must be aware about the version upgrades. We must keep upgrading the versions of our application, like the Scala version, or the libraries that we are using, because like there are multiple upgrades keep coming. The code fixes, the bug fixes are there in the libraries, in the compiler. So we must upgrade our application versions. Then the code reviews are very important, because that gives very useful like comments. Then we can use. There are many ways things can be written. there can be very good suggestions in the code reviews. One must use that. Then we should be having a verification plan and verification result in the pull request, like for a PR, what that PR will do in production, what should be the verification plan, how you will verify that your changes are working as per the expectation of after the deployment. Then one must also add the result of that verification in the same PR as a comment, which makes it complete. Because like if you're deploying any code, then the testing must be the part of the development process. Then we have a 15 factor app, which is very useful uh, for basically developing the application. It contains like uh, like the suggestions how one must develop these application, so anyone can like access this and Google. It's freely available. Then we have a sonar lint in IntelliJ as a plugin. We can use that. Similarly, there is a find sec bug, then code coverage, bot remover. These are some of the techniques by which we can write a really good code and maintain our old code. Then the good design plays a very important role, because like if we want to make our application is scalable, then we cannot keep adding anything to anywhere. The design should be good and scalable, and do not use hacks to basically get the work done. So I think that's it, and we are on time.
No, we missed the question answer time. But yeah, guys, like this was the idea to walk you all through the basic, some very of these generic concepts you might have already seen, right? Most of them you have already gone through, but you might not have used it in your project, or you seldomly use them. But the idea is now let's start focusing on them, because this is what actually client needs, client wants right now. So it's not about in logging, like it's not only limited to just view your logs, info level logs, and just debug them. No, there are 100 other types of matrices, tracing, and like logging, which is there. We have to start using them, learn about them. Similarly, the best practices that we talk about while developing, right? How to parallelize things, how to fasten your process by testing it locally, right? So we have to start using Docker Compose and all. And finally, this maintainability part. There are n number of tools which we haven't specified here, I think, which we all might be aware of. But the idea is whatever are the best tools for each and every use case. For example, for semantic check, linting check, formatting check, and so on, right? Security bugs check. So let's start implementing them. You can even ask your client, like if they do not use them, you should go and suggest them out. Okay, that buddy, like this is what we have been using, right, in our other projects. This is how it actually adds on the value, and why not we use them up? Uh,
Yeah.
and I think nobody will say no to you. Okay.
Yeah,
So
definitely we can introduce these things into our projects, and that's how we'll keep on maintaining our code and enhancing the application.
yeah, next time, let's connect. Next time again, we'll come up with some more these good techniques, best practices, maybe with more practical use cases. Maybe we are right now also developing some best practice case studies, which might be that is what we'll discuss next time. But thank you all for joining us, and do provide your feedback. Uh, but and let us know like what which all these whatever we have learned today, what do you find like most interesting in, and then maybe we'll talk more about it, right?
Yeah,
Okay.
definitely. Thanks everyone. Thanks for
Thank
joining.
you, Piyush, and thank you, Pulak. It was a great session. Thank you.